Hello guys, my name is Noel, and today I'm hoping to teach you guys and inform you about the atomic structure, for me particularly, Chemistry OCR Chapter 2.1.2. But then again, if you're studying another exam board, do not fear, because all the exam boards follow a simple and similar routine to each other. So I hope this would benefit you as well, if you are studying from another exam board. But as of now, I am specializing in Chemistry OCR A. So let's begin. This video will hopefully teach that isotopes as atoms of the same element with different numbers of neutrons, and the atomic structure with reference to protons, neutrons and electrons, given the atomic number, mass and ionic charges. And we'll also try some questions at the end to help you get used to this. Now, here we're going to talk about the protons, the neutrons and the electrons. So we see that we have our proton, our neutron and our electron. So here let's talk about the electrons. Our electrons are in reference to these. Our electrons will normally just orbit outside the nucleus. They just go around in a constant orbital ring, and they contain a negative charge. Normally they also have a different mass. You guys will want to remember these. These are very key masses. We'll have 1/2000 and -1. Now, normally if we just had a bunch of negative charges, this atom would be very negative. However, that's not the case. When you think about it, we have something called protons. Now these protons, they reference are in the nucleus. They are staying in here, and because of these little negative charges we have going around, they'll keep being attracted to the nucleus, keeping this nice little connection between both the nucleus and the electrons. Now these are different mass as well. We see that they weigh only 1. And that they have a relative charge of +1, which obviously is to compete against this and to make sure you have a neutral atom. Now lastly, we also have a neutron. At the moment, these are also in the same place in the nucleus. However, they don't really have much of an importance as of now. But as we go later on to the video, you'll see how much of an importance they have in this case. Now let's talk about isotopes. Isotopes are numbers that can vary. So let's say we have, for example, carbon 12. Now normally an isotope is an atom of the same element with a different number of neutrons. They will also have different masses. Now in our case right now, we're going to talk about carbon. So here we see that there's 3 different types of carbons. We have carbon 12, carbon 13 and carbon 14. Now you must be wondering what the difference is. If we look at this table right here, we'll see that firstly they have different weights. We have 12, we have 13 and we have 14. Obviously there must be a reason why this has happened. If we look closely, we see that all of these have a number 6 under them. You must be wondering what the 6 means, right? If we look at this, we have what we call the element itself, which is C. We have the mass number, which is the total mass of the product, as we see. And we have something called the atomic number. The atomic number relates to how many protons there are. And if we go back to the previous slide, we know that protons are the positive charges. So now, you're wondering why this might not match with, say, the 12, the 13, or the 14. Well, this is because the mass number is relevant to the protons and the neutrons. The electrons are a very tiny mass, therefore it doesn't really count to any of these. It's quite normally excluded. And as we have such a dense atom, you really can easily lose the weight. So, normally you would do, for this case, they did 12 minus 6 equals 6. And that gave us this number here to show the neutrons. And the same goes here. 13 minus 6 equals 7. And 14 minus 6 equals 8. So, obviously, we have different isotopes. And you might be thinking, oh, so it must have a different reaction. However, the case is that these will not have any effect to the reaction. And they will have all similar chemical properties. So, you're wondering why. The case is that in relation to chemical reactions, only electrons can cause a chemical reaction. So, this is obviously making you wonder the fact that, how come we have different types of isotopes for neutrons and they have no effect, whereas electrons can? Well, if we go over to the next slide, we see that we have something called ions. Neutrons can never leave the atom that it's in. However, you can transfer electrons. And when that happens, we have something called an ion. And ions are positively or negatively charged atoms or groups of atoms. The atoms are normally unbalanced, and this is due to the fact that, let's say, there's for carbon we had 12 and 6. So if it was, let's say, a C plus atom, the matter is, because it's 6 electrons and it's a plus, we know that there's definitely not the same amount of electrons in there. And in this case, it would be 5. Therefore, it will be able to take on another electron to become stable again. And that's why it's the only way to be able to have a chemical reaction. But now let's go back to the main idea of an ion. So here we have two examples. We have sodium with a plus charge and chlorine with a minus charge. Now we see the atomic number is 11 for sodium and 17 for chlorine. The mass number is 23 and 35. Now we know this is a plus, right? So we will recommend that you look at the proton number, which is the same as the atomic number, which is 11, and you look at the neutron number, which is 12, because 23 minus 11 will equal 12. Now if we have a plus charge, we'll know that it will obviously have 1 less electron, and therefore when you go 11 minus 10, you get plus 1. Same for chlorine. However, this time the atomic number is 17 and we have a mass number of 35. So it will be 35 minus 17, which equals 18. Therefore we have our neutrons. Now we have a minus charge. So this time, rather than adding 1, we'll have to lose a proton, or lose a positive charge in essence. So now we do 17 minus 18, which is minus 1, which means it becomes 1 more negative. So now we're going to try a possible question. So let's go and read through this. Carbon occurs in a wide range of compounds and is essential to living systems. Two isotopes of carbon are 12C and 13C. So now the question is, what is meant by the term isotopes? As we saw before, isotopes are atoms with the same number of protons and electrons, but with different number of neutrons. And if we check the mark scheme, we'll see that it is correct. Isotopes are atoms of the same element with a different number of neutrons. Now the second question is also, isotopes of carbons have the same chemical property. Explain why. Now, we both know now that isotopes refer to the change of neutrons, as stated here. But we both know that neutrons cannot affect the chemical reaction. and that the main property that will is an electron. So therefore we have to say that because there is no change of electrons, there will be no change in chemical reaction. And it says it here, isotopes have changes in neutrons, but only electrons can change chemical properties. And bear in mind, these are quite small marks. Even though they're little simple questions, you'll find them quite common in your breath paper. They will probably be your multiple choice questions, or even the questions that are breath, as it says in the breath paper. So they'll start with this topic and then go on, getting more enhanced and more advanced as we move on. Now, this is the point where you guys would pause the video and try this question out, and then after you think you're ready, you just press play and we'll go through the question quickly. So right now, you'll pause, try the question out, and once you're ready, return to the video. So, if we read the question, that the group 2 element magnesium was first isolated by Sir Humphrey Davy in 1808. Magnesium has 3 stable isotopes, which are magnesium 24, as we see here, magnesium 25, and those are the only 2 that are at the moment necessary for the question. Now it says, complete the table below to show the atomic structure of magnesium 24 and magnesium 25. So, firstly, you would want to find out the protons, as it says here. Now, as we said before, the atomic number here is referenced with the protons. So we could put 12 here and 12 here. And as we know that none of these are ions, that the electron number should be the same. So now we have both the proton and the electron numbers settled. Now, as we talked about before, to find isotopes, you must subtract the mass number from the proton number. So now we go 24 minus 12, which equals to 12. And therefore our neutron number here is 12. However, for magnesium, we now have 25. And now we minus this again with 12 to get 13. Now, as you see, these are very simple questions, and though they do offer you little marks, they will make a huge effort to add a lot of these questions in your exam, and these could benefit you a lot in the exam. These 1 and little 2 markers are nice and easy marks for you to get, you know, so you guys should always be able to practice these questions and make sure you're very good at them, because they're the most easiest questions you can come upon, and they're the best way to get marks. So I'd like to thank you guys all for watching, and I think you guys, if it did help you, you should drop a like, because it does help and it shows to me that you guys find the videos helpful and gives me a little bit of motivation to carry on. It would also be nice if you guys had any questions, you just ask it in the comments and I'll be able to help you guys out if I can, hopefully. But anyway, let's hope we get a nice community that can help each other out as well. I hope to plan and upload more videos with regards to chemistry and maths. Obviously, if you guys have a topic in mind, you can also put that down in the comments, and the ones that I feel like will be possible to teach, I'll give it a go and post them as well. And if you guys could give any feedback on the video, anything that was wrong or anything that was actually good, and it'll help me improve the videos more and make sure it's more watchable for you guys. And lastly, share the video to help others. If the video helps you, then why not help your other peers as well? And with that, I'd like to thank you all for watching and see you again next time.